Good afternoon, everyone. Welcome back to College Trigonometry. So I have not received any question or no concern, no discussion. So I assume that everything will be is okay to you guys. Yes, we have only a few more weeks to finish the course. So I want you guys to spend more time and try harder, and again, don't ever hesitate asking me any question, okay? Just post it on the discussion board and I'll try to answer your question as soon as I can. Okay, so in the previous video I introduced the definition of vector, and we learned how to create vector by picking 2 points on the 2-dimensional surface, and we connect them 2 points with a segment, right? And if we give them an arrow, so we have a vector, and because vector is a segment with direction. I mean, because we see that vector is created by 2 points, and points, they have coordinate, right? So vector, they also have coordinate. Okay, so today I want to talk about the coordinate of vector. Okay. Coordinate of vector. Okay, and then every time we talk about coordinate of vector, we talk about the components of that coordinate, right? So the first one I want to talk about vector component. The reason I'm using plural S over here because they have x and y component, the same thing as for the point. We also have x and y components. Okay. I want you to take a look at this vector. First of all, okay, I have the coordinate system, and on this coordinate system I draw a vector, okay, and I call this a vector AB, okay. Now I want to translate it. I want to translate this vector. I want to translate parallelly this vector to a position we call standard position. Okay, so I translate this parallelly to a standard position. So this is a standard position. Okay. So I call this a point B, P, and this point O. So I actually translate point A to point O, the origin, and I translate point B to point P. Okay. So as translate this vector to this position, the position that has the endpoint of the vector at the origin, we call the standard position. Okay, this is standard position. Okay. Standard position. Okay, and vector OP is called standard vector of vector AB. So vector OP is a standard vector of vector AB. Okay. So, you know, in the coordinate system we see that there are many vector which has vector OP as the standard vector. For example, I can draw another vector here, right? And I move it to the standard position, and I still consider OP as the standard vector of that new vector. Okay. So the coordinate of point A now is moved to point O, and point B is moved to point P. Okay, the coordinate of point B become the coordinate of point P. Then the coordinate of vector AB, it becomes the coordinate of vector OP. Okay, coordinate of vector AB becomes coordinate of vector OP. And you know that the coordinate of point O is the origin. It's 0, 0. Okay? And the coordinate of point P, I say this over here is XP in YP, for example. Okay? Then the coordinate of point P is actually become the coordinate of vector OP because the coordinate of point O is the origin. Then I can write over here, and in turn, coordinate of vector OP becomes coordinate of point P. Okay, and the coordinate of point P, what I have over here is I call it XP and YP. Okay, what is XP? XP the X component of point P. Alright, because there's an X component of point P, this is right here. It represents from here to here, right? It represents from here to here. Right. XP is this thing, okay? And YP is this distance from here to here, right? This is YP, right? And this is XP, okay? Alright, now let me draw this a little bit more. Let me elongate this. So the point A over here, they also have coordinate, right? The coordinate of the X component of point A is from here to here. Okay, from here to here, right? I call that XA, right? And the X component of point B is from here to here, right? I call that XB. Okay, right? And the Y component of point A is from here to here, right? The Y component of point A. So this is YA, right? And the Y component of point B is this. It's from here to here, right? It's this YB. Okay. So what do you see over here? What do you see? You will see that YP here, okay? YP here because my whiteboard doesn't have it doesn't have the grid, so I couldn't draw perfectly. But if it has the grid, okay, you will see that YP has the same distance, the length, okay, is the length from here to here, or I say YP is the same as, this is the same as what? This is the same as YA minus YB. So YP from here to here is the same as this one. Okay, it's the same as YA minus YB. Okay, the same as YA minus YB. Okay, in terms of the length. And XP, right? XP, just imagine, XP is from here to here. Okay, XP is from there to there, right? It's the same as the distance from here to here. So when you take this minus this, give you XP. Okay. Well, again, because my picture doesn't have the grid, it's very hard for you to recognize. But if you draw this on the grid paper, okay, then you will see that XP, the distance from here to here, is the same as the distance from here to here. And the distance from here to here is you take the big one, xb minus xa. Okay? That's why we can find the coordinate of vector AB, okay, by finding the coordinate of vector OP is the same as you find the coordinate of point B, and the same you find when you take xb minus xa and yb minus ya. Okay, let's say it again. The coordinate, okay, coordinate of vector AB, okay, is the same as, okay, the coordinate of it is actually the coordinate of point B. And in order to find the coordinate of point B, okay, you take xb minus xa, yb minus ya. Instead of ya minus yb, you give you that distance, but because ya minus yb is the different direction, so we have to take yb minus ya instead of ya minus yb. Okay. So the coordinate of AB vector is notated as, okay, it's notated as AB equal to, instead of using parentheses for the coordinate, right, for the point, right, but we're going to use this kind of bracket. xb minus xa, okay, comma, yb minus ya. Okay. This formula is come from this picture. Okay. And xb minus xa, xb minus xa and yb minus ya, we call that vector components of vector AB. Okay, remark. xb minus xa, yb minus ya is component, okay, is component of vector AB. Okay. I can add a little bit here, you know, actually this is also the same as xp comma yp, because I already told you the coordinate of vector AB is same as the coordinate of vector OP, and the coordinate of vector OP is the coordinate of point P. So that's why coordinate of vector AB is the same as the coordinate of point P. Okay. For example, well, it seems to be very a little bit confusing because of the picture, right? But it's not really that bad when you find a coordinate given the coordinate of 2 points. You can find the coordinate of a vector easily. Okay. Example. Okay. Given 2 points. Given 2 points. Okay. Point A, we have a coordinate is 3, 5. Okay. Okay, it's just regular notation for the coordinate of the point. Okay. But the coordinate of vector you have to put equal. Okay. And point B, you have the coordinate is -2, 1. Okay. I want to find coordinate of vector AB. Okay. Okay. So I'm going to use this formula, right? AB. So So you put a b vector. Remember, you always do b first and a later. So you take the head minus the tail, okay? Head minus tail. So xb, okay, write it down, xb minus xa, comma, yb minus ya, okay? So xb, remember, always head minus tail, okay? Head minus tail. Head is b, b minus a is the tail, okay? So it will be -2 minus 3, comma, 1 minus 5. So the coordinate will be -5, -4. Okay? Very easy. So given the coordinate of 2 points, you can find the coordinate of vector created by those 2 points. Of course, it depends on the direction also. If you calculate vector BA, remember vector BA is minus of vector AB, right? We already learned in the previous video. Then of course you just need to change the sign, so it becomes 5, 4. Okay. Well, you can apply the formula to xa minus xb because vector BA, A is the head now, so A is the head, so you take head minus tail. xa, so 3 minus minus 2 is 5, 5 minus 1, 4. Okay, same thing. However, you just need to change the sign. You just put the minus sign in front of this, then you change it. Okay. Okay. And because you see that we can find the coordinate of a vector, it means that we can find the magnitude of that vector also. You see over here the magnitude of vector AB is actually by applying a Pythagorean theorem. You see this triangle right here, you see that? This right triangle right here. If you can apply the Pythagorean theorem over there, then you can find the magnitude of the vector easily. Okay? So in the second step, I want to talk about the magnitude of a vector. Okay? Magnitude of a vector. So this is the first step. Okay. So given a coordinate of 2 points, you can find the magnitude of the vector, and then the notation for the magnitude of the vector is AB, right, with the bar like that, right? In the previous video, we already talked about this, equal to, okay, xb minus xa, same thing, xb minus xa square. I apply Pythagorean theorem, so see, this square plus this square, okay, plus yb minus ya square. So it's nothing else, it's just applying Pythagorean theorem. And this is give you the coordinate, the magnitude of a vector. Okay. So if they give you coordinate of 2 points, they give you you find the coordinate of the vector, then you can find the magnitude easily, right? So I can give you the example using this formula right here. Using the example right here. So I'm going to go ahead and find the magnitude of this vector AB here. Okay. So we already have the coordinate, right? So you just square that, right? So xb minus xa is -5, right? So -5 square plus -4 square. So give you what? 25, right? 25 plus 16, right? So to give you what? 141. There you go. So the magnitude will be 41, right? 25, 16, yes, 41. Alright, so as long as you know the coordinate of the vector, you can find the magnitude of that vector easily. Okay. So you see that any vector can be displayed geometrically on the coordinate system by using its component, x and y component of that vector. Okay. More interestingly, the x-axis and the y-axis of the coordinate system can be also represented by a vector. We call those vector unit. Okay. So on the second part of the video, this lecture, I want to talk about unit vector. What is unit vector? Right. Unit vector. Any vector whose magnitude equal 1, we can say that unit vector. An x and y axis of the coordinate system can be also represented by a unit vector. Okay, we call that I vector and J vector. Okay. So first of all, unit vector, okay, is a vector whose which magnitude equal 1. Okay, magnitude equal 1. And x and y axis can be represented by unit vector. So the x-axis can be represented by a unit vector called vector I. Okay. So a y-axis can be also represented by a unit vector called vector J. So remember, I and J here, they are unit vector. There are many unit vector. Later on, we're going to learn how to find a unit vector with respect to a arbitrary vector. Okay. So I and J are unit vector. Okay. And the coordinate of this unit vector is I vector equal to 1, 0. Okay. And J vector equal to 0, 1. Okay. Now I want you to take a look at this picture one more time. So I'm going to draw an arbitrary vector. Okay, arbitrary vector. I call this vector AB. Okay. Again, I will translate it to the standard position. Okay, it's right here. On B, P here, B become P, A become O. Okay. Okay. You will see that if I apply, the parallelogram method of adding vector, I can split vector OP into two parts. Okay, into two vector. Okay, I split into this vector. I split it also into this vector. Okay. These two vector, when you split vector OP into, we call that. Let me name this. This is a OP1 and OP2. Okay. So vector OP1 and vector OP2, we call that component vector. Okay, component vector. Okay. And because they are component vector, then of course they have the coordinate. Because they are vector. Okay? Because they are vector. Okay. So what is coordinate of that? What's coordinate of that? Well, again, because my whiteboard doesn't have the grid, So I just go ahead say that over. Maybe this is 2 and this is 3, okay? 2 unit and this is 3 unit. Then the component vector has the coordinate. So vector OP1 has coordinate will be 1 because it's on the x-axis. Okay, so we have the component will be 2, 0. Okay, and vector OP2 on the y-axis, then we have a component. We had a coordinate that will be 0, 3. Okay. Okay. And the coordinate and the unit vector that represent x and y axis will be over here. So this will be I vector here because it's only 1, right? 1, and this will be a j vector here. So j vector here. Okay. So I vector here and j vector here. Okay. That's already have 1 and 1 0 and 0 1. Okay. Okay. And because you see the vector AB is translated to vector OP. And vector OP is split up into 2 smaller vectors using a parallelogram rule. And vector OP is on the x and y. Vector OP1, OP2 is on the x and y coordinates, x and y axis. And x and y axis represented by vector I and j. It means what? It means that any arbitrary vector can be written in terms of vector I and vector j. Okay? Remember that. Any arbitrary vector can be written in terms of vector I and j. Alright. What is that? I have a coordinate of vector AB. Okay, I just make them up, okay? The header coordinate is 1, 2. Okay. Then I can write the coordinate of vector AB here in terms of vector I and j as follow. I can write it as 1i plus 2j. Okay. I can give you another example when the components of vector are negative. Okay. Example 2 is 1, 2. What if I say a vector CD and it has 2 components, is -3 and -4. Then I can express this vector in terms of vector I and j as follow. -3i. Okay. And because this is minus, so be minus 4j. Okay. So again, you can express any vector, arbitrary vector, with respect to vector I and vector j easily. Okay, just another way of writing a vector. Okay, and you see this form with I and j. You see this a lot in physics if you have a chance to take physics 1 and physics 2. Okay. Besides, any vector can be also expressed by using it unit vector. What I mean over here, that given a vector v, you can find a vector unit with respect to that vector. Okay. So I'm gonna make a star here. Given a vector v, we can find a vector unit. And this vector unit, of course, have magnitudes 1, and they have the same direction as vector v. We can find a vector unit which has the same direction as vector v. And the formula to find this vector unit is, so I'm gonna write it like this: vector u represent vector unit with respect to vector v. So vector u sub vector v. So this is mean vector unit with respect to vector v equal to vector v, over the magnitude of vector v. Or sometimes they can write like this. Sometimes they can write it as the coordinate of vector v is v1, v2, over the magnitude of vector v. The magnitude of vector v is very easy to find. If they give you the coordinate of vector v already, you can find a magnitude. I can give you a quick example. It's pretty simple. Example. What if I want to find unit vector of vector v which has the coordinate 3, 1? Find unit vector of vector v, and this has coordinate is 3, 1. So we have to use this formula. You have to use this formula. So I'm going to box the formula here. So first of all, we need to find the magnitude of that vector. The coordinate we already have 3, 1. Solution. So you can find the magnitude by using the Pythagorean theorem. So it's absolute of 3 squared plus 1 squared, right? So this gives you square root of 10. Then you can find the unit vector. It's notated as u with respect to v. Equal to the coordinate. So we 3, 1 over square root of 10. Then it gives you. So you can write this in terms of I and j. So it will be 3 over square root of 10 I. Plus 1 over square root of 10j. And because unit vector is a vector, right? Unit vector is a vector, then of course we can express that vector in terms of I and j. Sometimes I and j we call the basic vector. Basic vector. You know, if you read some textbook, you may see that I and j might be called basic vector. Alright. So in the previous video, we talked about how to add two vectors geometrically. Remember we using the parallelogram rules, and we also using the first method. You know, the head of the first vector become the tail of the second vector, and you add it. So far we learned. We know that vector has coordinate. It means what? It means that we can add two vector or subtract two vector, or even multiply a number by the vector by adding the components or subtracting the component of those two vectors together. So in the third part of the video, we want to add two vector with its coordinate. So I'm going to put algebraic operation of vector. Okay. First of all, we want to add two vector. So what if I have vector u, it has coordinate is u1, u2, okay, and the vector v, that coordinate is v1, v2. And we also learned that when you add or subtract two vectors, it gives you another vector. So when you add vector u to vector v, it gives you another vector whose coordinate will be u1 plus v1. So when you add vector u to vector v, it gives you another vector, and that another vector has coordinate u1 plus v1, comma, u2 plus v2. Similarly, you do the same for minus. So I just put the minus here, so it will be u1 minus v1, u2 minus v2. And the same thing for when you multiply a vector by a scalar quantity. You just need to multiply each component of that vector by that scalar. For example, I want to multiply vector u with the scalar k. Okay. Then you just need to multiply that scalar by its component. So we give you k u1, comma k u2. Right. Sometimes we call it a scalar multiplication. Okay, scalar multiplication. Alright. And it's very easy. Okay, I can give you a quick example here. You know, whatever we learn about vector in this course, everything is just basic, you know. Actually, they just want to prepare you for physics or some basic math concept when you go to a higher level that using vector. Example. Okay. So I have two vector u is that expressed in terms of I and j. I 2i minus j. Okay. And this one is actually 2, -1. Okay. And another vector is 4i plus 5j. Vector v, 4i plus 5j. Now I want to add these two vectors together. Okay. I want to find vector u plus vector v for part A. And for part B, I want to multiply vector u by 3 and subtract it by 2 times vector v. Alright. Of course, when they ask you to add, it gives you another vector, right? Of course, then they want you to write that vector in order pair form, or you can use the I and j vector to express your final answer. Okay? Solution. Very easy, guy. First of all, I'm going to do u plus v, right? U plus v gives you another vector. So let me call that vector is vector w. Okay. So I will add the component Okay, this one I can write it using order pair form, 4, 5. So I add the x component, the I component, so be 2 plus 4 give you 6. Right? Negative 1 plus 5, right? Negative 1 plus 5 give you 4. So this is your final answer. And you can express as 6i plus 4j. Okay, as the final answer. You can write this, or you can stop over here, that's up to you. Okay, but I recommend that you write both way because it just help you guys get more used to it, you know. So part B, you want to find 3u minus 2v. Okay, first of all we need to find 3u. So find 3u, if you multiply 3 by its component, so give you 3 times 2, see that? 3 times 2, 6. 3 times negative 1, negative 3. Okay. And minus 2v. Okay. So you do what? You do, oh, you just need to do 2v. Then later we subtract from each other. So 2v, 2 times 4, right? 2 times 4, 8. And 2 times 5, 10. And now we got two vectors already, we can subtract it from each other. So 3u minus 2v is equal to 6 minus 8. 6 minus 8 give you negative 2. Okay, we got 3u minus 2v, right? So 6 minus 8. Negative 3 minus 10, negative 30. Alright, you can stop over here or you can express in terms of I and j, so it'll give you negative 2i minus 13j. Okay, that's it. Very easy, right? So, for this video we learn many things, right? However, you see that we never learned how to multiply two vectors together. Okay, so in the next lecture, I will be talking about that, and that next lecture will be the last one of our course. Okay, I want to give you guys more time to study for the final and test number 3. However, even though that the next lecture will be the last one, if I have time, I can give you more video. Doing more exercises so that you guys have more opportunity to be exposed to many different type of vector problems. Okay. However, for the lecture number 2 of vector, that's all for today, and hopefully that you guys can get something. I mean, if you guys don't get it, again, don't hesitate posting your question on discussing board, and I'm willing to answer that question for you. Okay, and I'll see you in the last video. Bye bye.